On December 21, 2025, just days before Christmas, Yellowstone National Park served up something way more intense than snowfall and festive cheer. In the frozen early morning hours, the Black Diamond Pool, tucked within the park's hydrothermal network, violently exploded. Boiling water, scalding mud, superheated steam, rocks shooting dozens of feet into the sky. It wasn't just a puff of steam. This was a full-blown hydrothermal eruption, raw, unpredictable, and loud. And if that deja vu feels real, it's because it is.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
This marks the second major hydrothermal blast in Yellowstone in just 2 years, following the 2024 explosion at Biscuit Basin. That one shredded boardwalks and forced long-term closures. Now, with Black Diamond Pool blowing its top, the anxiety is back and so are the headlines. So, let's get one thing straight up front. This was not a volcanic eruption. Scientists were crystal clear. No magma, no ash cloud, no rising dome of doom. Just Yellowstone doing what it does best, flexing its geothermal muscles through an explosive pressure release. Still, what went down at Black Diamond Pool is nothing short of wild. Here's what happened. A sudden drop in pressure beneath the pool triggered a near-instantaneous flash of groundwater into steam. That rapid phase change released an enormous amount of energy, violently ejecting material skyward. Steam, boiling water, mud, shattered rock launched like nature's own geyser from hell. It didn't come with any fire and brimstone, but it sure looked like it. And while this might seem like a random outburst, it was actually part of a larger, subterranean chain reaction. Secondary effects showed up fast, particularly at nearby Panic Pool. Sensors there recorded temperature spikes, water level swings, and a sharp rise in gas emissions. In plain terms, heat was rerouting underground. Fast. That's how interconnected Yellowstone's hydrothermal system really is. One pool blows, and others respond because beneath the surface, everything is wired together by a chaotic, fault-controlled plumbing network. So if you're wondering whether this means Yellowstone's supervolcano is waking up, the answer is still no. There was no magmatic seismicity, no unusual ground uplift, no helium-3 anomalies, no harmonic tremors. All the usual warning signs you'd expect before a volcanic eruption. Absent. This was pressure meeting weakness in the rock and unleashing energy in one brutal burst. The science behind it is fascinating, if a little terrifying. Yellowstone's hydrothermal system runs on residual heat from its still hot, upper crustal magma reservoir. That heat powers more than 10,000 thermal features: geysers, hot springs, mud pots, fumaroles, all of them operating on razor-thin margins of pressure and temperature. And sometimes, if the pressure builds up too high or if mineral seals degrade, things go off like this. That's what happened here. And the scary part, these events are incredibly hard to predict. Unlike volcanic eruptions, which usually give off warning signs over months or years, hydrothermal explosions can hit with almost no notice. In the hours leading up to the Black Diamond blast, there were tiny earthquakes, but they were so small, so subtle, they barely registered. We're talking microseismicity below magnitude 2.0, tied to fluid movement and structural shifts, not magma. So yes, there were clues, but not enough to see this coming. And this isn't Yellowstone's first rodeo with this kind of chaos. The 2024 explosion at Biscuit Basin damaged infrastructure and permanently reshaped parts of the landscape. That area is still partially closed, by the way, because the ground hasn't stabilized. Now, with Black Diamond Pool erupting and triggering activity at Panic Pool, we're seeing a pattern, an increasingly unstable hydrothermal system that's becoming harder to manage. Geologists aren't panicking, but they are paying very close attention. This isn't about volcanic catastrophe. It's about understanding a system that's unpredictable by nature and increasingly active. Because what happened at Black Diamond Pool wasn't just an isolated blast. It was a data point in a much bigger picture. A picture that includes shifting underground heat paths, interconnected faults, fractures sealed with minerals that slowly dissolve over time under harsh, acidic conditions. When those seals fail, pressure escapes. And when pressure escapes in a flash, you get this. What's even more unnerving is how fast changes at one thermal feature ripple through the whole system. After the Black Diamond Pool eruption, data from Panic Pool came in fast. Gas levels up, temperatures swinging wildly, water levels dropping and rising unpredictably. It wasn't just a reaction. It was a chain reaction. And it shows why it's a mistake to study these thermal features in isolation. Yellowstone is a giant, boiling jigsaw puzzle where the pieces shift when you're not looking.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
It also proves how crucial monitoring has become. Scientists now rely on a full suite of tools: seismic sensors, thermal cameras, gas spectrometers, GPS, INSA, or anything to catch the subtle signs of change. And even with all that, forecasting a hydrothermal explosion is still nearly impossible. That's because the key variable, pore pressure in rock fractures, can't be reliably measured in real time. The rock is too heterogeneous, the plumbing is too chaotic, and the seals that hold back the pressure, they degrade silently, until suddenly, they don't. That's why this latest blast matters so much. Not because it's a harbinger of doom, but because it's a brutally honest reminder: this system is alive. And even when it seems calm, it's anything but quiet under the surface. And the public, they're spooked. Again. Because every time Yellowstone makes noise, people assume the supervolcano is about to blow. The problem isn't the science, it's the messaging. Hydrothermal explosions and volcanic eruptions are fundamentally different. One is a surface-level, water-driven event. The other is a deep, magma-driven catastrophe. But try getting that across in a headline. That disconnect between public perception and scientific reality is becoming a problem. People panic when they shouldn't, or worse, ignore warnings that do matter because they've been desensitized by sensationalism. It's not helping that these eruptions are coming more frequently. The system at Black Diamond Pool has been unstable since 2024. Scientists think that's due to the progressive breakdown of its hydrothermal seal, basically the natural cap that keeps pressure contained. With silica-rich rock dissolving under heat and acidity, more pressure escapes, more frequently, less predictably. That means fewer big eruptions and more small, violent ones. It also means more attention on secondary pools like Panic Pool that may be next in line. Because if one pathway opens up, the pressure doesn't just vanish, it gets rerouted, redirected. It migrates across fault lines, through fractures, into new reservoirs. The entire Yellowstone hydrothermal system is a game of underground dominoes. And if you're still wondering why this matters, even if you're nowhere near Wyoming, it's because Yellowstone is a global reference point. It's the most studied volcanic system in the world. What we learn here affects how we monitor geothermal systems everywhere. It sets the standard for how to integrate data across thermal, seismic, and chemical channels. Even something as subtle as a 0.3 degrees Celsius rise in groundwater at Turquoise Pool can be tied to a spike in CO at Fountain Geyser miles away. That's the level of detail we're talking about now. Because in a place where over 10,000 thermal features are fueled by a common heat source, no event is truly isolated. Every eruption, every anomaly, every fluctuation, it's all part of the same living, breathing system. A system that doesn't erupt often, but never sleeps. So no, Yellowstone isn't blowing up. But yes, it did just explode. Again. And if this trend continues, we may be entering a new normal. More hydrothermal instability, more frequent blasts, more eyes on the park's plumbing than ever before. Stay curious, stay informed, and the next time someone screams Yellowstone is erupting, you'll know exactly what kind of eruption they mean. If you're fascinated by the wild mechanics of this geothermal beast, hit that like button, share this video with your Yellowstone-obsessed friend, and drop a comment below. Should we be more worried about the plumbing than the volcano? And of course, subscribe for more breakdowns on the chaotic beauty of Earth doing whatever the hell it wants. Because here's the thing, Yellowstone doesn't need magma to be dangerous. It has plenty of drama bubbling just beneath the surface without even touching the supervolcano narrative. The Black Diamond Pool eruption wasn't just some quirky little geyser hiccup. It was a violent release of pent-up geothermal rage. The kind that rearranges landscapes in minutes. The kind that proves, once again, that nature doesn't care about park schedules or Christmas mornings. And let's not forget the timing. This wasn't a summer afternoon when tourists are everywhere snapping selfies. This was deep winter. Frigid air, icy boardwalks, limited access. Had this blast occurred during peak season, the outcome could have been a lot worse. No one was hurt this time, but that's mostly luck, not preparation. These events come without fanfare, without warning, and without mercy. Now, the fact that Black Diamond Pool had already been under close watch since the last eruption isn't lost on anyone. The long-term instability there didn't just pop out of nowhere. Since 2024, The pole's hydrothermal seal the rock and mineral barrier, keeping all that pressure in, has been degrading. Acidic, high-temperature water has been slowly dissolving that seal like a corrosive countdown clock. And December 21st, that's when the timer hit zero. This kind of deterioration doesn't happen overnight. It's part of a broader trend scientists have been trying to model: how silica-based seals within the hydrothermal system erode over time. It turns out, Yellowstone isn't just hot and steamy, it's chemically aggressive. All that acidic water, all that heat, it's slowly eating away the underground plumbing. And when the seal finally fails, that's when things go boom. And it's not just about where it happens, it's about what it affects. Remember Panic Pool? It wasn't just a bystander in this mess. As soon as Black Diamond Pool erupted, Panic Pool lit up like a geothermal Christmas tree. Spiking temperatures, unstable water levels, a sudden rush of gases. That's the domino effect Yellowstone is famous for. These aren't isolated pools. They're pressure valves in a massive, unstable machine. Tug on one, and the rest start to creak. This interconnectedness isn't a theory, it's been observed in real time. What happens at one pool shows up in the data miles away. Fault-controlled conduits carry heat and pressure through the crust like unseen highways. Think about that. You're watching what looks like a sleepy spring, and across the basin, another one is reacting. That's not random. That's Yellowstone's version of a group chat, except instead of texts, it's steam bursts and CO spikes. Speaking of gas, emissions are one of the main things scientists are watching post-eruption. Carbon dioxide, hydrogen sulfide, volatile compounds that tell us what's happening underground without needing to drill. Gas spectrometry has come a long way, and after this explosion, those sensors were working overtime. Not just at the eruption site, but across the park. Because again, what happens in one location is just a clue. The real story is told across the system. And let's talk about the data, because there's a lot of it. Before the eruption, the only real signals were microquakes, tiny ones, sub to 0.0 in magnitude. Harmless on the surface, but underground, they were whispers of fluid migration, of cavities collapsing, of fractures snapping open. Not the kind of quakes you'd link to magma movement. These weren't the kind that say supervolcano incoming. These were the kind that say pressure's shifting, and the seal's about to fail. That's the nuance the media often misses. Not every rumble means eruption. Not every steam plume means doom. There's a whole spectrum of geothermal behavior in Yellowstone that has nothing to do with volcanic activity. And that's what scientists are trying to communicate loudly, repeatedly, and often unsuccessfully. Because the public hears eruption and immediately thinks Pompeii to 0.0. But hydrothermal explosions, they're different. They're shallow. They're driven by water, not lava. And they're much more likely to happen without warning. That's what makes them dangerous. Not because they're world-ending, but because they're impossible to forecast with any precision. You can have all the sensors, all the models, all the historical data and still get caught off guard. And let's not ignore the broader implications. Yellowstone is the most monitored geothermal system on the planet. Every spike in temperature, every drop in pressure, every unusual gas reading, it's logged, graphed, and scrutinized. And still, Black Diamond Pool managed to surprise everyone. That should tell you something about the limits of even our best science when it comes to natural chaos. Now that the eruptions happened, the focus shifts to surveillance. Monitoring priorities are shifting fast: gas emissions, water chemistry anomalies, ground deformation, especially via INSAR and GPS. They're looking for subtle patterns, not just at the site of the explosion, but across the board. Because again, this isn't a local issue, it's a systemic one. And yes, the supervolcano still sits quietly below it all. Dormant, not extinct. But don't get it twisted, this hydrothermal activity is not a sign that it's waking up. The kind of eruption that would signal a true volcanic event. It would come with years of buildup. We're talking sustained inflation, harmonic tremors, geochemical anomalies, including rare isotopes like helium-3. None of that is happening. The data is clear. No magma is moving. No eruption is imminent. So why does this keep getting framed like Yellowstone's about to blow? Because fear sells. Because context is complicated. Because violent steam explosion doesn't get as many clicks as Yellowstone supervolcano erupts on Christmas. But the reality is far more grounded and, in a way, more fascinating. This isn't some apocalyptic horror story. It's a masterclass in geodynamic complexity. The system is active, yes, but it's always active. What's changed is our visibility. Our ability to observe, to connect the dots between a water temperature blip at one spring and a gas flux surge at another, to see how a tiny thermal anomaly at Turquoise Pool corresponds to CO levels at Fountain Geyser. This is the new frontier, finding the hidden patterns in the noise. And if you're the kind of person who gets nervous about Yellowstone, and honestly, who isn't after watching a plume of boiling water erupt into a snowy sky, here's what you need to know. The danger isn't what Hollywood thinks it is. It's not the lava. It's not the ash cloud. It's the water. It's the steam. It's the pressure bursting through weakened rock, with no warning, and no way to stop it. That's what happened on December 21st. That's what could happen again. But don't let that ruin the magic of Yellowstone. This place isn't just dangerous, it's breathtaking, alive, and a reminder of how thin the line is between calm and chaos. It's also a laboratory, a teacher, and yes, a bit of a diva. 1 minute, it's a serene winter wonderland. The next, it's blasting mud into the sky and rewriting the terrain. So next time you see footage of steam exploding from a quiet-looking pool, remember, it's not just a tourist attraction. It's a warning shot, a natural pressure valve popping off in the most dramatic way possible. And while the magma below sleeps, the hydrothermal system above definitely doesn't. Keep your eye on it. Respect the science. And maybe stay off the boardwalks when the ground starts hissing. And don't think this is just some fluke. What happened at Black Diamond Pool could easily happen again somewhere else, or even there again. Because the system isn't resetting back to normal. It's shifting. The seal that once kept things stable, gone. The underground pathways that used to quietly transport heat and fluid, now wide open, rerouted, volatile. What scientists are seeing isn't a one-off, it's a symptom of long-term instability creeping across the hydrothermal map. And that instability isn't random. It's been brewing since Biscuit Basin's eruption in 2024. That blast reshaped the terrain and damaged infrastructure so badly that parts of the area are still closed. A year later, Black Diamond Pool explodes. Coincidence? Not likely. These events are lining up like chapters in a story Yellowstone's been itching to tell, and now, we're all paying attention. The question now is, how much of the system is at a tipping point? If hydrothermal seals are degrading at multiple sites, if subsurface fluid pathways are opening and connecting features that used to act independently, then this isn't just about managing risk at a single pool. It's about reassessing the safety of the entire basin. And that's exactly what scientists are doing, recalibrating their models, reevaluating what's normal, and watching thermal features that haven't stirred in years suddenly behave like they've been jolted awake. But there's still no magma on the move. No volcanic red flags. Just the Earth doing what it does best, reminding us who's really in control. So yeah, the Christmas eruption didn't come with lava or a volcanic winter. But it came with a message: don't underestimate the power of steam. And if you're into watching the planet flex in the most unpredictable ways, hit that like, drop your thoughts in the comments, and definitely subscribe, because in a place like Yellowstone, every plume of steam is the start of a bigger story. And you won't want to miss what happens next. Thanks so much for watching. If you made it all the way to the end, you're officially part of the small percentage of people who don't just click away, and that means a lot. Before you go, I'd love to hear from you. Drop a comment below and tell me your thoughts, your ideas, or even what you'd like to see next. I read every single one of them, and your feedback genuinely shapes the direction of this channel. If you enjoyed the video, tap that like button. It tells YouTube this content is worth sharing. And if you haven't already, hit subscribe and turn on notifications so you don't miss the next upload. We've got more exciting videos coming, and trust me, you'll want to be here for them. This channel is just getting started, and your support helps it grow faster than you realize. Thank you again for spending a part of your day here with me. Stay curious, stay motivated, and as always, take care of yourself. Until next time, I'll see you in the next video.